Second law of thermodynamics. There are two statements of second law of thermodynamics. The first is Kelvin-Planck statement. Kelvin-Planck statement says that we cannot have a cyclic process which convert entire amount of heat into work done. That is, say if this is a source and some heat is extracted from it, then a self-operating cyclic process cannot be such that this entire heat Q1 gets converted into work, and as a result, in reality, some amount of heat is also rejected in every cycle. So what does this mean to us? It means that we cannot have a 100% efficient heat engines. Heat engines therefore have limitation based on Kelvin-Planck statement. That is, the efficiency which is given by work done upon heat supplied. That is, the amount of heat we supply to the engine. It will always be less than 1. Carnot built a heat engine which is claimed to have maximum efficiency among all heat engines when operated between same two temperature ranges. Say source is at temperature T1 and sink is at temperature T2, then between same two temperature T1 and T2, Carnot engine claims to have highest efficiency. The efficiency in case of Carnot, which is W by Q1, can be written as Q1 minus Q2 by Q1, because work done is equal to heat supplied minus heat rejected by the engine per cycle, which is 1 minus Q2 by Q1. In case of Carnot, the ratio Q2 by Q1 is equal to T2 by T1. The ratio Q2 by Q1 is proportional to the respective temperatures. The temperatures we are using here in Kelvin. So the efficiency of Carnot engine turns out to be 1 minus T2 by T1. And for the same two temperature ranges T1 and T2, this is the most efficient heat engine. Let us see another statement, which is Clausius statement. In Clausius statement, it says we cannot have a process which extract heat from lower temperature and supply it to higher temperature without any other change or without producing any other effect. So the Clausius statement affects refrigerator or heat pumps. Say some heat is extracted by the refrigerator at colder temperature T2 and it is rejected to higher temperature of the surrounding, say Q1. Then this process cannot operate by itself. That is, to reject the heat at higher temperature T1, there must be done some work. So this is why refrigerator uses electrical energy. So what we have, when heat Q2 is extracted and supplied to a higher temperature at T1, then some work is also required and Q1 is equal to Q2 plus W. We do not have efficiency for refrigerator because that would be meaningless. Instead, we have coefficient of performance K, which is defined as the ratio of heat extracted upon work done. For extracting some amount of heat, if we do lesser amount of work, obviously better is the refrigerator. This coefficient of performance can be written as Q2 divided by Q1 minus Q2. Here again, in case of Carnot refrigerator, as heat is proportional to the respective temperature, so coefficient of performance is T2 divided by T1 minus T2. Not to forget, the temperatures are used in Kelvin. Thank you.